For the next paper, Mr. Ho-Chang Chen, he will present the paper entitled Evaluating Common Statistical Method Used for Species Distribution Modeling of 2-3 species.
Okay, thank you, Chairman, kind introduction. And hi, Sawadee-ka. Good morning, everyone. My name is Ho-Chang Chen. I'm from Taiwan, the graduate student of Department Forestry, National Zhongxin University. Today, I would like to talk about evaluating common statistical methods used for species distribution modeling of 2-3 species. So if you have any question, I'm happy to answer your question after that section. And there are 5 parts in my presentation, which is from introduction to conclusion. So let's talk about today's topic. Modeling species distribution pattern has become an important thing in spatial ecology. We just collect the species data and the predictor and use the statistical method to generate a prediction map of the species pattern or the plant community. And that will become a useful information for use the fieldwork surveying, conservation planning, and explore the potential consequence of the climate change. And the data resource, we integrate the 3S technology, greatly enhance the worker capacity to meet that challenge by giving them ability to describe a pattern in natural over broader spatial scale than ever before. But even we have better than the traditional manner, it is still hard to describe a species pattern accurately, since we always solve the problem like before. Species trait have been proved to influence the success of the success, and different methods have different modeling results. Sample size and the data quality determine the prediction power, and predictor contribute a different importance for predicting the tree species. And that study focused on the formal factor to know the influence. And the target species we choose from the central Taiwan, a widespread species, Chinese Boga tree, and that we call the CGT. CGT with a scattered distribution and wide environment tolerance. And the other one is a clump species, Formosana rhododendron, that we call the FR. That species always form the pure forest and have specialized in lifestyle, can grow at a mildew and acidic soil environment. And the study, we use the A model algorithm that's envelop the decision tree, discriminant-analysis, logistic multiple regression, maximum entropy, domain, bioclean, general linear model, and the maximum likelihood to predict the potential two species. Next, we could see our study area is the rectangle shape, which encompasses the Huishun forestation. Huishun forestation is the representative forest in central Taiwan. And so far, the elevation range from 444 to 24 altimeter, and the species CGT and FR sample obtained by the GPS, and we collect from the Dongfeng and the Guangdao 2 sites. And the objective of this study want to check the 3 points. The first, testing how the different species trait affect the model performance. And the second, evaluating the ability of spatial extrapolation with each model. And finally, determine which models are used for predicting the two species. And then I'm going to talk about the flowchart. This study, there's a 3 component in my study plan. That's involve the data collection, data processing, and the model development and the validation. And initially, I prefer to talk the data collection. We generate 5 predict variables, that's including elevation, slope, ascent, terrain position, and the vegetation index. And the vegetation index from 2 spot file image to generate it. The second, we obtain the species by the GPS, and the total number we get 186 sample for the CGT, 179 for the FR species. we further combine those data points and to make sampling designs. And the second part, the data processing, we have two components, that's sampling, designing, and the overlay and the clip. At the beginning, we talked the sampling design. We split the Dongfeng data and randomly choose 2/3 of Dongfeng data for model development, and we call the Dongfeng best model. And the remaining Dongfeng sample were used to test the data. And the second design, we keep the same Dongfeng best model for model training. And the other one, to test the data far from the long distance way with the more than five parameters, the distance, we extract the Guandao test data. Let's try to evaluate the ability of spatial extrapolation with each model and to know the relation in different spatial scale and the model performance. How's the difficulty and what's the difference? And that slide shows you overlay all the layer and input the species to cut suitable and non-suitable environment attribute data and further to attempt to our model to calculate model parameters. And the next part, we'll talk about the model development and the validation. And we use the A model algorithm to predict the potential happy. That's before we talked mentioned before we talked the DT, DA, LNR, MaxN, domain, BioClean, GLN, and the MLO model. And we evaluate the model performance by the kappa value. Kappa could celebrate 5 levels from low to high and almost agreement. And we use the independent t-test to determine have the significant difference in the mean kappa or not between the two species, and use the split sample validation one from the Dongfeng and far from the Guandao to test the data set. And finally, determine which models are used for plant species. And we rank the model performance and show you according to mean kappa value. And all the process before we talk the model development and the validation was repeated with the 10 rabbit case. So next part, we will talk our study result and the finding. And I prefer to divide the 6 part to tell my topic. That's envelope evaluating the relative importance and evaluating the performance species for all algorithms based on the independent test. And the third one, compare the model performance based on the mean kappa value. And further, to compare the percentage of a potential area and evaluating the ability of spatial extrapolation of each model. Finally, we use the MaxN as an example to show you how difficulty of spatial extrapolation. So at the beginning, let's talk the SD1 case. If we follow the processing, the total number should be around the 1600 combination. That's a large amount calculating. So we try to reduce the data dimension and improve our calculating efficiency. I summarized that table to show you about the relative importance of each predictor variable. And we could find the number. The number 1 is mean the high importance, and number 5 is mean the low performance. Overall, the predicting the two species, and we find the elevation, slope, and the terrain position have a relative high importance for predicting the two species. So we use those variables to predict our best model. And we summarize that's the line curve to indicate the model performance will influenced by 2 factors. One species trait, and the other one is a different modeling algorithm. And the variance in model performance across the species traits greater than the model different modeling algorithm. In addition, we according to independent t-test and find the mean kappa value modeling the FR species overall higher than the CGT species. So the ecological trait will influence the model performance. And the second, we compare the model performance based on the mean kappa value, and we choose top 3 algorithms, and we find the DT, MaxN, and domain have relative high importance for predicting the true tree species. And the third one, we compare the percentage of a potential happy area. Before we talk, the DT, MaxN, domain not only have outperformance for predicting two tree species, but they also those models could reduce the area fields less than to 10% to the entire study area for the CGT, and less than 5% of the entire study area for the FR species. So that's good for predicting the tree potential habit, those models. And moreover, we evaluating the ability of spatial extrapolation of each model, and we could find the Likert diagram indicate the model, the mean kappa value have a similar change by the mean kappa value, and in SD1, its mean in the short distance less than 1 parameter had a relatively smaller extrapolation. In SD2, it's the Guangdao test data far from 5 parameter distance, and we find have the similar change by mean kappa value. The total number we could get when we increase the spatial extent, they will decrease all the model performance. And finally, I further to show a prediction map as an example by MaxN and try to evaluating ability of spatial extrapolation. And everyone can see the orange color is our suitable habit, and the dark green is our background point. And the red point, the sky blue point is our target and the test data. And we added in the pink and pink and bright green, the triangle is our background point. So let's go to see the SD1 case. And we find the model predicted near around the Dongfeng site. They will predict very well and have good performance. While the test data far from the Guangdao site, it's a serious problem. All the test data falling through the wrong prediction with the CGT cast. And we also see the FR species cast and adding the background point to show you that in Dongfeng and the Guangdao, the test data. And in SD1, they have the similar change with the CGT cast. The model all can predict very well in the near around the Dongfeng site. But when we try to over-predict far from the 5 parameter, another watershed place, the total number cannot predict very well and have a serious problem. And we make some conclude when we only use the Dongfeng best model and integrate the topographic variable, they only apply them within the limited geographic without significant error. But we try to apply a large spatial scale that have a serious prediction problems. And according to above results, I draw some conclusions. The first point, we analyze the species trait as shown in t-test results. The modeling species with the widespread distribution like the CGT are generally more difficult than modeling species with a clone distribution like the FR species. And the second, DT, MaxN, and the domain were the best 3 among the 8 models, and the 3 models generate high potential area of 2 species and substantially reduce the area of a field survey, and they were much suited for predicting the potential habit and helped the fieldwork investigation in the future. And moreover, the spatial extrapolation with each model will attempt to know the relation, so as we find the model based on only applying with the limited geographic, they could predict very well. But when you try applying a large spatial scale, they will causing the mislinking, have a serious problem. And finally, the study limit, that's the study is the primary stage. We still lost some key factor and not take consideration. And model only based on the topographic factor cannot perform very well on the spatial extrapolation with a long distance because some key factor not take consideration. And future job, we will do the improve our data quality and add derivative predictors and also attempt to use high spatial resolution data and hyperspectral image data. Actually, we already acquired the hyperspectral image data and the LiDAR information, and we'll do the processing in the future. Try to improve our model performance, and which could apply it with a large spatial scale. That's my today's topic. Thank you for your attention.
Okay, if you have any question, please. Okay. Please use a microphone behind.
How many species, rhododendron species in your tour study area?
More than 1,000 tree species. More than 1,000. It's a representative
Many,
forest.
many genus.
Yes, many genus and mix.
Mhm.
Very complicated.
Mhm.
Yes.
Yeah, I'm very interested in rhododendron species, and we have 2 or 3 rhododendron species in Mongolia. Just I'm interested in. Also, this 2 species, also 1 genus or different genus species you are studying?
Sorry, what?
And 2 species you are talking about, and only 2 species. That's 2 species and from 1 genus and all different genus species.
Yes.
Different genus?
Two species.
2 genus, yeah?
Yes.
Okay. Thank you.
Thank you.
And more question? Okay, if no more question, okay.
Thank you for your presentation.
Thank you.
You showed the kappa coefficient reliability.
Yes.
How about the agreement percentage? Agreement.
Sorry, it
Yes.
means the overall
Agreement.
agreement.
Yes. For the validation. I know test. There are 2 tests. Reliability and agreement.
Agreement. And sorry, I didn't catch the keywords.
Yes.
Can you state it briefly? Can you state it briefly? Or? Okay, we can talk after that section. Okay, thank you.
Okay, so we would like to thank Mr. Ho Chen to give a very interesting research to us. Give a big hand to you. Okay. For the last paper, will be presented by Mr. Li Gan from Institute of Space and Earth Information Science, the Chinese University of Hong Kong, with the paper entitled Cloud Subsidence Causes by Hydrologic Loading Derived by pH in SAR, accessible to Bangko Lake in the Tibetan Plateau.
Good morning, everyone. First, I would like to introduce myself. My name is Li Gan. I come from the Institute of Space and Earth Information Science, the Chinese University of Hong Kong. And my topic today is about the lake dynamic and the global warming in Tibet Plateau. Due to the global warming of the last few decades, the climate change in Tibet Plateau, which caused the glacier ablation and lake dynamic. Okay, let's move to the next slide. Our study area is Bamuto Lake. It's located in the east of Bandung country, north of Linqing Tanghua Mountain, large perfection, Tibet Plateau. It has a height of 4,555 meters. It has an area about 200 square kilometers, while the basin area is about 5,000 square kilometers, about 25 times larger than this area. Precipitation of this area is about 300 to 400 millimeters per year, and the average temperature is about 0 to 2 centigrade. Its main supply is 10 surface runoff, mainly by precipitation, and no glacier exists in this basin area. So this lake was not affected by the glacier melting. This is quite important because we finally contribute of this lake arising by permafrost ablation and its increasing of active layers, and the other reason is precipitation increase. And to the south, okay. Okay, this one is Namso, our main study area, and to the south is Namso, the largest lake on Tibet Plateau. Okay, and this is the lake dynamic in Tibet Plateau. We could see that most of the lake present in red color, and this means the lake, the level of the lake rise in the last decades from 2001 to 2010, and those few lakes present in blue color means that they decrease its level. And my study area is here. It arises because this data was derived by ICET satellite altimeter, and the Bamso is not a very large lake, so we failed to get its elevation, get its level change. However, the Namso Lake is quite large, about 2,000 square kilometers, and we obtained the altimeter information by using MVSat RA2 data. And the first observation is in 2002, and the last is in 2010. Unfortunately, we missed about 3-year data because the satellite seems not to work in this when it covers this area. But still, we get the altimeter information for Namso increase about 2 meters in this 8-year range. However, without altimeter, we still get the area information of Namso, and we derived this information by using SAR amplitude files and the coherence maps of SAR images. And we could see that in 2003, the area of Bamso is about 208 square kilometers, and in 2008 it increased about 35 square kilometers. That is to say about somehow 17%. But we could see that most increasing was contributed by the year from 2003 to 2006. In this slide, we could see that the amplitude images that acquired in July in 2003, 2006, and 2008. And in the below right, we could see that this is the coherence map of images. And in the blue area means low coherence, because when the SAR image is co-registered to another, it will perform a parameter called coherence. This coherence means the ground change. Is for the ground change. When the ground is not changed much, it will perform high coherence, just like this ground area. And but water, however, it always fluctuates, so it will lose coherence when we co-register two SAR images. We could see that in 2003, especially in this area, there are not so much the lake is not so wide in 2003. However, it increased in 2008. We also use the PS INSAR method to derive the line offset velocity field in this area. This is the coverage of our SAR image. We could see that it covered Bamso and the Namso and the mountain of Linqing Tangula. And this is the master image that we choose the image acquired in April 13, 2006 by considering both temporal and perpendicular baseline. We acquired 27 C-band ASA image cover observed by MVSat. But when we process the data, we used two methods to identify PS points by dispersion of amplitude and signal by SNR of this phrase. But in the second step, we delete those images with large perpendicular baseline to avoid big noise. And okay, this is the LOS line offset velocity field of this area. We could see a bowl-shaped substance around the bilateral area. This may be introduced by the mass loading caused the elastic deformation of crustal. We could see around the lake its maximum LOS velocity is about 2 to 3 millimeters per year. We also draw a profile of this line about 31.22 to 31.25 north, just across this area to show its bowl-shaped subsidence. We could see that in lake area, because the fluctuate of the water, it completely lost coherence, so no PS points derived in this area, which also confirms this method is quite stable. Okay, in the next, we will show two time series that derived by our method. The first, we used a strong temporal filtering to subtract atmosphere delay, because when you use sun image, the most nicest item is atmosphere delay. We use the threshold for about 2 years to avoid this effect. But in this way, high frequency ground deformation could also be felt just like when the flood season comes, the lake will get large. So according to the elastic mass loading model, it will also introduce the ground subsidence. We could see that this time series with strong temporal filtering, that we could see the ground subsidence is somehow linear